second example, we're working letter B. Solutions of sodium hydroxide and acetic acid are mixed. Again, an acid-base reaction. Beginning this equation on my work page, for the letter B, sodium hydroxide, written as NaOH, reacting with acetic acid, HC2H3O2 acetic acid. Acid-base chemistry is a neutralization process. We can also think of this as a double displacement. Sodium will go to acetate, H goes to OH, forming water. When a water molecule forms, it's just that it is a neutralization reaction. Sorry, I tripped. Na goes to acetate, so the salt that is produced is sodium acetate, and the driving force here is molecular water. Now, knowing that this particular question makes sure that we dissociate any strong electrolyte. Sodium hydroxide is a strong base. It will 100% dissociate. Acetic acid is a weak acid. It is left in molecular form. Water is a molecule. It will not dissociate, leave together. Sodium acetate is a salt. It is a strong electrolyte and will need to dissociate. So taking the next step from our molecular equation into a net ionic equation, we would see that sodium hydroxide dissociates, acetic acid stays together. Water stays together, sodium acetate will dissociate. Break apart the strongs, leave together everything else. And when I'm noticing any type of spectator ion, I'm only seeing the sodium ion that would be eliminated. So the answer that I would produce or put into my final box there on my worksheet, the acetic acid with hydroxide ion forms molecular water and acetate. When a strong base reacts with a weak acid, molecular water forms and the salt sodium acetate will dissociate, leaving us a weak acid plus hydroxide producing water and the conjugate base of that acid, C2H3O2 negative. Now, the question that goes with letter B is asking, if acetic acid is a weak acid, equal volumes of molar solutions are mixed of the acid and base. Will the solution pH be 7, greater than 7, or less than 7, and explain? Understanding that a strong base and a weak acid will not produce a solution of equal pH values of H plus and OH negative, it will not be neutral 7. As a matter of fact, this conjugate base of that weak acid will hydrolyze. And let me explain. Hydrolysis, is reaction with water. When a weak acid lets go of its proton, and it will to the sodium hydroxide, this resulting ion undergoes a process called hydrolysis. In other words, C2H3O2 negative, this is the conjugate base of the original acid, acetic acid. The conjugate base of this weak acid reacts with water, and when it does so, we see a proton transfer. The proton is placed right back onto the original acetate, creating acetic acid, leaving the solution basic. The hydroxide ion that forms through the process of hydrolysis creates a pH that is greater than 7. The solution will be basic. If you would like additional page reference, page 699 in your textbook gives you further examples of the process known as hydrolysis. This is covered in chapter 16, which is yet to be covered in class.